Hello everyone, my name is Ajay. So in this video I'm going to explain you about the problem called as rotate array. So for suppose if you are given array of integers like 1, 2, 3, 4 and 5, and if you are given k equal to 2, then you have to rotate this array from the right side 2 times, k times. That means each time you have to move the last element to the first index. So let us see how we can do that. So after first rotation, the array will look like this. The last element will go to the first index. Okay, so the last element is 5, so it comes to the first index and all the elements will be then after. Okay, this is after first rotation. Let's see how it would be after second rotation. So now the last element is 4, now it goes to the first index, so it will be 4, 5, 1, 2, 3. So this is the output. So the problem is to rotate the array k times and result the output. So after 2 rotations I got this output. So we need to solve this thing. So for solving this, we can actually, there are quite a few methods for solving this, but one of the efficient method is by using reverse operations. So if you perform few reverse operations on this array, you can actually get the output. So let's see how we can do that one. So here if you see, the output array is starting with the element 4. So this element 4 is actually at index 3 in the original array. Index 3. Okay. So how to find this index? First you have to find that particular index. So for finding that index, you can simply do length of array minus k. That is, the length is 5 and k is 2. That will give you 3. So once you get this index, you just divide the array into 2 subarrays just before that index. Okay. So once you divide that array into 2 subarrays, you have to actually reverse the left subarray, then the right subarray, and then again you have to reverse the complete array. So let me show you. So first you have to reverse the left subarray, which is from 0 to 2. That would be 3, 2 and 1. And then you have to reverse the right subarray, which is from 3 to 4. That would look like 5 and 4. Okay. So once you reverse these 2 subarrays, you have to reverse the complete array now. So let me do that. So that would be 4, 5, 1, 2, 3. So if you see, we got the output. So by this way we can actually get the output. So this is the way we can solve this problem. So let's see how we can code it. So here if you see, I have written the prototypes of the function. So this is the rotate function, which is taking array of integers and input k, and I have written the prototype reverse function, which is taking array of integers, the start index and the end index of the array, where we have to actually reverse. So as I said, we have to perform 3 reverse operations. So let's do that one. So first perform the reverse operation on the left subarray. So the left subarray, I'll pass AR as the array, and I have to pass the start index and end index of that array, which need to be reversed. So the left subarray start index is 0. That would be 0. Okay. And the end index of the left subarray is L minus k minus 1, which is 3 minus 1, that is 2. So if you do length of array minus k minus 1, you will get this end index of the left subarray. That would be AR dot array dot length minus k minus 1. Okay. So this is the reverse operation for left subarray. Now we'll perform the reverse operation for the right subarray. That would be reverse of AR. So for the right subarray, you have to get this index. For getting this index 3, you can just do length of array minus k, or would be AO dot length minus k, and the end index is the last element of the array. That would be AO dot length minus 1. Okay, so this is for the right sub array. So once this two reverse is done, reverse operations are done, then we have to reverse the complete array, which is from 0 to n minus 1. So for doing that, I'll call the reverse function again, pass the array. So here the start index is 0 and the end index is the last element, which will be AO dot length minus 1. Okay, so after performing these three operations, I will get the output. So before that, let's see, there are two scenarios where we can actually optimize this solution. The first scenario is when k equal to 0 or k equal to length. So when k equal to 0 or when k equal to length of the array, there is no need for us to perform any rotations. Why? Because if k equal to 0, that means you have to not do any operations, any rotations. If k equal to length of the array, for suppose if the length of the array is 5 here, and if k is 5, so after performing 5 rotations, you will get the same array again. So at that scenario, no need to perform any rotations, right? So when k equal to 0 and when k equal to length of array, then no need to do anything, just return it. So I'll just write that code here. If k equal to 0 or k equal to array dot length, then just return by doing nothing. Okay, this is one scenario, and the other scenario is whenever k is greater than length. So in that scenario, there can be error, when k is greater than L. For suppose, I'll erase this thing. For suppose if I'm having an array like this, 1, 2, 3, and k is 5. So let me write all the operations after each rotation. First rotation, second rotation, third rotation, fourth and fifth. After first rotation, it would be 3, 1, 2. After second rotation, it would be 2, 3, 1. After third rotation, it would be 1, 2, 3, which is same as the original array. And let me complete this. After fourth rotation, it would be again 3, 1, 2. After fifth rotation, it would be 2, 3, 1. Okay. So here if you see, after 3 rotations, I'm getting the original array. But then if I do 2 rotations in this scenario, I'll get the output, which is these 2 rotations. So instead of performing all the 5 rotations, if I just do 2 rotations, then I'll get the output. So how to get that number 2? So for getting this number, you can simply use k mod of length. Let me show you that. This occurs only when k is greater than length of array. So let me write if k is greater than array dot length, then k equal to k mod array dot length. Okay, and also if k is greater than array dot length, then I may get index out of bound error. Why? Because if k is 5 and length is 3, when I do array dot length minus k, that would be 3 minus 5, that would be minus 2, minus 1, that is minus 3. So minus 3 is an invalid index in an array, so it will throw an error. So to avoid that error and also to avoid unnecessary rotations, we are using this thing here. So whenever k is greater than array dot length, we are just making k equal to k modulus array dot length. So that would give the number 2 as I shown here. So that is about the solution of rotate array. So let me implement the reverse function. So for implementing the reverse function, so you can actually do a reverse function on an array in a linear time with a constant space. Let me show you how we can do that one. So for suppose if I'm having an array 1, 2, 3, 4, and let me have 2 pointers, start pointer and end pointer. So you have to actually swap this start pointer and end pointer first. So after swapping the start pointer and end pointer, you will get the result like this, 4 and 1, and in between it will be 2 and 3. And after swapping the start and end pointer, you have to increment start pointer and decrement end pointer. So after incrementing start pointer, S comes here, and after decrementing end pointer, E comes here. So after incrementing and decrementing, you have to again swap the start and end, which is 2 and 3. So after swapping 2 and 3, it would be 4, 3, 2 and 1. Now again you will increment start, that will come here, and you will decrement end, that will come here. So whenever start is greater than end, then that means the reverse operation on the array is done. So you have to stop the operation there. So that way you can actually reverse an array in linear time with a space complexity of big of 1. So let me implement here. So while s is less than end, you have to swap the start index element and end index element. So for that I'm using int temp, and I will have s in that, and AR of s would be AR of n, and AR of n would be temp. Okay, and I will increment start and I will decrement end pointer. Okay, so by this way you can reverse the array, and you can reverse the array in the linear time and without any extra space. So this is about the reverse function. So overall this is the solution for rotating an array from the right side for k times. Let us see the time complexity for this solution. So as I said, so this loop actually iterates half of the array length, which would be n by 2. If the array length is 4, then we are just iterating 2 times. That would be n by 2, it is only 2. So which is nothing but, if it is n by 2, we assume that the time complexity would be big O of n, which is linear time. So for reverse array we have the time complexity of big O of n. Now here we are performing 3 reverse operations here. So here we are actually sending the left subarray, which is having 3 elements in this example, and here we are performing the right subarray. We are reversing the right subarray, which is having 2 elements. So adding these 2 gives us 5, which is equal to n. Which is equal to n, and this one we are having 5 elements. We are reversing 5 elements, which is equal to n. So it is n plus n, that would be 2n. So 2n is nothing but time complexity would be big O of n, which is linear time. And coming to the space complexity, so here we are not using any temporary array or any other extra space for performing this rotate array operations. So it is a constant time, so that would be big of 1. So that be all. So you can also find the code in the description of this video. So if you have any questions, you can actually post them in the comment section. Thank you for watching my video. Thank you.